name's Daniel Hinojosa. I'm from Albuquerque, New Mexico. So Neil Ford talked about this morning from Breaking Bad. My connection to it, I don't know what part I am on the color wheel, but I live about a mile and a half from Walter White's house, or the fictional house. Just so you know, they had to fence it all in. If you haven't seen the show, a certain food item gets placed somewhere on the house. I won't go into details, just in case you haven't watched Breaking Bad yet. Just a little bit about that. All right. Anyway, so my name's Daniel Hinojosa, and we're going to talk about some design patterns. So here's some contact information here. You can follow me on Twitter at Tdd Immutability. And here's this information. Now, how do you get this information? Well, you can head over here. Sorry I had to make a QR code. I saw that was the latest and greatest thing, and now I feel shame for doing that. So you'll have to do it the old way. GitHub.com, Hinojosa, and this will be design_patterns_training. This is from my training material for design patterns. So this one's design patterns training, all underscores, Devnexus _2022. Okay, all information is there, and we are good to go. And you should be able to see the URL there, and we will go ahead and continue. So here it is. I'll give you 10 seconds here. 10, 9. Excellent. Okay, so all material is here. When you get back into your work environment, whether that be at home or at the office, if you are back at the office, try some of these patterns. These are opinionated. Some of these, what I'm going to show, are the classic design patterns from 1994. But some of these are, hey, let's start to use the cool stuff within Java. And so that's the goal for this particular presentation, to bring everything into kind of like our modern world. So here are some of the goals for today, and let's see if we can. Oh, it looks like the answer is no. All right. Well, goals. I know it's a little bit hard to see here. How about I do that? There we go. So. Hide complexity from users and structure, Command 7. Anyway, goals, hide complexity from users, prefer TDD. Oh, how many of you are absolutely in love with TDD, test-driven development? 1, 2. Oh. I have a pretty big group here, but it was like 1, 2, 3, and we are done. All right. So we'll talk about TDD. Immutability for the most part. So we've kind of taken on a new way of development. I don't know if any of you have started to use records yet, but records are purely immutable. The days of maybe setters are going to sunset, no pun intended. But you know, how we deal with objects and whether we're mutating, how does that have an effect with everything as far as the design pattern goes? So we'll talk about that. Avoiding side effects. So if possible, a lot of these design patterns used a lot of void. And usually when you have a return type of void, you have a side effect. If you have not really grokked what a side effect is, it is printing to the monitor, sending over to the networks, writing onto a disk drive, something that happens that you cannot attain any representational value out of it. And so therefore you can't make an assertion on it. That's why unit testing anything that has a particular side effect is pretty much untestable. So what we like to tend to do in a good architected software is try to isolate those particular side effects. So that way we know this part's going to be really hard to test, but if we really minimize that and then really just focus and test the core parts, then we get more testing coverage from it. So upgrade Java to the latest. I have a great group here, so welcome. How many of you were stuck in Java 8 at work? It's a good number, or bad number. I don't know how to interpret that. Java 11-ish, okay, another good number there. 17, 18, you ride the wave. All right, ride waivers. There they are. So I'm going to try to sell you on some of the latest and greatest stuff for Java. No way that within 1 hour I'm going to be able to talk about all the patterns that there are, but the ones that I find particularly interesting, particularly static factory, particularly builder. We'll see if that should stick around or not. Singleton, whether that should hang around. State pattern, strategy, chain of responsibility, adapter, maybe visitor. I'm thinking of putting that one on the chopping block. I don't know. We'll take a look at that. Okay. So these are some of the goals that I want to talk about today. If you download this particular project, you will see this design patterns .zip right down here. Try it at home. Try it at your office. Here's where my slides, my document is located. I also have one here called Testing the Undesirable. So this one was kind of like try to do a modern take of Michael Feathers' book on how to test legacy applications. So a different kind of presentation. I'm going to refer to that for one of the patterns, and that's going to be particularly the decorator pattern. So again, the goal is not really to just regurgitate what the 1994 book was on learning design patterns, but particularly how we can modernize that for 2022. So I'm going to start with one of these, and I'll expand along the way. So in this particular class, one of the things that I usually start off with is, a TDD. And through that TDD, I start off with, hey, let's do particularly like a programmer. Let's create via the tests on how we create a particular programmer. And we see this. Programmer first name, last name, birth date. Today's date. Like, testing is hard. Like, TDD is one of those things that, hey, I'll give you the steps in 5 steps. Boom. But it's one of those things that's, simple, but not easy, right? We see what those steps are, and I think many of us already know what test-driven development is. But it's always the stuff like this, the things you can't control, the side effects, things like today's date. So one of the problems we have with this and trying to unit test this is that just like the 70s or 80s song goes by the Steve Miller Band, some of you know this song. How does it go? Time keeps on slipping, slipping, slipping. The future there. Into the future. There we go. So time keeps on slipping, slipping, slipping into the future. So we need some way to plug in today's date. Well, if you're thinking, whoa, hey there, why don't I just do, instead of this one right over here, why don't I just do local date time now, or local date? I think this one's a local date. Why don't I just do that? What's the problem with this? Well, Steve Miller Band again, right? Time keeps on slipping, 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 slipping into the future. Okay? So that unit test is going to run great for this year, like especially we're calculating someone's birthday. It's going to go great until their birthday. And then all of a sudden your CI is you're going to not run, and you're going to get a fail on that CI. Why? Again, new clock, right? Things kept changing. So how do we unit test things like that? So that's why I started off with something like this. And I'll get to a particular design pattern. In fact, I'll get to 2 on this one. So we're bringing in a particular supplier, okay? So I think most of you know what a supplier is. We kind of have like 4 identities and functions. Supplier, right? A function, predicate, and what's the other one? Consumer, yeah. So supplier is like grandma on a holiday. Going to give you gifts, right? That's what grandma does. She supplies you with stuff. Me on Christmas, I like getting gifts. I don't give anyone anything. I'm a consumer. So, but the function is give me something, I'll do something in return. Now this one is going to be injecting in a particular supplier as part of this programmer, okay? And we get to this point where, we want to run our particular unit test, and away we go. Let's see if this is my MacBook Air, so things might be a little slow. No, it isn't. Oh, great. There we go. So everything is testing exactly right. So then we get to the point here on, you know what though? Look at the way we create this. New programmer, James Gosling. Oh, that fit out pretty well there. James Gosling, local date, he was born in 1955 on May 19th. And today's date is 2018. Time keeps on slipping into the future. Put in a fake date. If you put in a fake date, that unit test is always going to run. And that's the best part about it. Now, if you're looking at this, then you're probably thinking, I don't know, do I want my end users to keep doing that? Like, do they always have to plug in that particular date? No. So, one of the things that we can do, again, do your unit test, but there's often some sort of way to get around it, to make it look good. And so for something like that, let's do a test, a static method factory. And in fact, it's kind of ironic that I'm doing this because there was a time where I really dreaded static because they were, I thought they were untestable, but it's the way that you use it, not particularly static itself. So I was kind of blaming the wrong thing. But let's take a look here. So what if I have programmer, but this time instead of that new, how about I create something like programmer of with that first name? So how about James Gosling? Ooh, très bien. Look at that. And whenever he was born, so we will do local date of 1955, 5/19. And that's it. Okay? Hide the complexity away from the users. So all they have is this of that we have here. Now this doesn't exist yet, just like the tried and true Java programmers or TDD Java programmers would do. Here, let me do an assertion here. Let's do an assert that programmer, and I thought I had assert that already in here, but maybe not. Here, let's bring that in. Very good. And is not null. All right. That's the best I could do, I think, for this one. Or I could test like James Gosling or whatever, but I think that will do. So of does not exist, so I will go ahead and create that method, and here it is. Static programmer of. So let me just go ahead and finish this, and I will have first name, I will have last name, and I will have birth date. Beautiful. Now, what shall I return from this? Now I know I should probably just run my fail test first, but I have about 48 minutes left. So how about I do programmer in here, and then what I'm just going to do is I'm just going to feed that right in, right? So let's go ahead and bring in first name, let's go ahead and bring in last name, and let's go ahead and bring in birth date. But the constructor actually takes one more item. Sorry, that might be a little small there, but it's supplier of local date. Well, this is the real one, right? This is the one that, you know, people in the real world will be using. And of course, we can shave that down just a little bit, and there it is, okay? Now, what was the benefit of this? One is that for the outside world in this universe, people can call programmer of. But for, you know, the designers of this, and again, this is a small conceptual class, but for the designers of this, I could lock it up, I think. Let me go ahead and run those tests to make sure that everything is still running, and away we go. Yeah, there it is. And so everything is green bar. So now I have the best of both worlds. I am able to test, right? I am able to do my unit tests. I am able to fake out the current date. Okay, it's always 2018. We're talking pre-pandemic here. And we have a way for people in the outside world to create a particular programmer. This has become a convention using of within Java. I'm not making it up. So what I'm going to show right here is effective Java, Joshua block, creating and destroying objects. This just happens to be one of the books that is a must-have on your shelf, like physical book. Yeah, digital books are great, but get effective Java 2nd edition, where he lays out a lot of, I wouldn't say rules, but good things to adhere to. And one of them is creating and destroying objects. Consider a static factory method instead of constructors. And the reason for it, very numerous. Let me highlight the bold ones here. So one advantage of static factory methods, unlike constructors, they have names, right? With constructors, you have the same name over and over again, but what if you want to describe things a little bit more, okay? Like this one, big integer probable prime, which is on the JDK. That means something, that has some sort of meaning for you. And he delineates, a lot of different advantages. Unlike constructors, they're required to create a new object every time they're invoked. We can do laziness. Third is, unlike constructors, they can return an object of any subtype as well. So you can, let's say you have an abstract class, you can return any subtype that you like. So on and on. So all great stuff. And I think one more, fourth advantage, can vary from call to call as a function of input of parameters, depending on what kind of parameters you want to do. Anyway, all that is amazing. And we see it everywhere. We see this convention. And in fact, you know what? One last thing that I wanted to show on this article. Here are some of the conventions I was talking about. And you've seen these. .from. So like, hey, let's go to class .from. Means that there's a conversion type of. We're aggregating or creating something. Value of to convert, to a more verbose alternative. Get instance. There's a create here. Maybe I should have used a create. But these are becoming more and more of a convention style within Java. That's what I'm doing here. In fact, local date.now, local date.of, stream.of, you've probably seen those. Of is becoming more and more prevalent within the JVM. This is a static factory. So something that you might and hopefully would use and find a lot of use cases for it. But I also did another design pattern, and that's the strategy pattern. Yay, okay? So I think the strategy pattern is absolutely relevant, but how we go about it is probably going to be different than the 1994 book in that what we use are just going to be functions. The functions are everywhere. Lambdas are everywhere. So one of the theses that I have for today is for you to get creative. You don't have to use the old style, for lack of a better word, design pattern that you've read from the Gang of Four book. You have a lot of new language features that you can use to make things a little bit better, okay? Not, saying anything negative about the Gang of Four book. That's absolutely great. I learned a lot from it, but due to some language features, some things are going to change. That's all I want to say. All right. Also, one question here. Why did I bring in a supplier? Anybody want to guess that one? Why not just a local date? Why not just like inject in a local date? Boom, done. What's funny about that? Yeah, I'll get your sign language. Yeah, it always changes, right? So if I have this object in memory, right, and it just happens to still be in memory when this person has a birthday, well, I have wrong information, right? It's good to have fresh information. But this is the strategy here. The strategy is, hey, I may give you like a fixed date for my unit testing, or it may just be local date now. I extracted that part. So nail two of them. Now, the strategy pattern, in this particular repository, which I would love for you to take a look at, but the idea for that is, or for this particular presentation as well, is here, let's go to strategy pattern. This one I created for, and me and a friend of mine created for Albuquerque Java User Group in 2012. What? And I'm kind of proud of myself on this one because I had no idea what was about to happen in 2014. 2014 is when JDK 8 came out, right? So it was only 2 years away. Some of you are like, wait, JDK 8 was 2014? Anyway, so right in here we see interface, and I think there's the date right there, yeah. May 30th, kind of close. May 30th, 2012. So this is a little bit of old code here. But I had a strategy with an interface with one abstract method. Wow, was I usually don't have like the the knowledge of what's going to happen here in the future, but this one worked out great. So this was my strategy pattern problem, and so my strategy was that I'm going to have a number accumulator where I'm going to accumulate things, and then I'm going to bring in this strategy, plug that in, and then accumulate whatever it is that I needed. Where my strategy was, hey, maybe I will, multiply numbers together or sum these numbers together. Boy, did that work out. But this is the classic design pattern. What do we have now? Well, we don't have to do all that. That's the thing about what we're talking about today, right? Because we could just do what? Stream of 1, 2, 3, 4, or whatever. And then we can reduce. And what we're going to plug in here is, what the next values are going to be. So this right here is just going to be my strategy. Whether I want to multiply or not, and I think that ought to work. Oh, which one am I using? Let's see. Stream of, reduce is already it, right? That's already a reduction. Yeah, there it is. Okay, so here's the stream reduce. What is the strategy here? Lambda, right? We don't have to do that extra work anymore. Lambda's kind of does everything now. And so we can use lambdas for our advantage for just about everything. All right. So which one am I going to pick on next? Builder. How many of you have like builder pattern all over the place in the code base that you work with at work? Okay, some of you are like, how many of you use Lombok for your builders? Oh, wow. You're stoked. Yeah, I love you, Lombok. I love you forever, Lombok. But so the builder pattern, let's talk about that one. I think it's going to stay. I don't think there's anything different that we do about it per se. Maybe use Lombok and use the annotations to create that particular builder pattern. That's kind of cool. And one of the reasons why I think that the builder pattern, anyway, here's kind of the classic one where you usually have some sort of builder and you kind of trigger things off with one particular method. Usually it's .builder, and that gives you a builder object in return. Then you can start to add things in whatever order that you would like. So in this case, espresso drink maker, let's add some shots, add some whip, add some sprinkles, skim milk, whatever it is we like, and then deciding what it is that we want to create. Then we will hit a build. So again, Lombok is very favored. I have no opinions on Lombok. Kind of odd. I'm probably like one of the only people who don't have that. But also, one of the other things that I learned just recently as well, let's say I want to create just like a standard kind of simple class here. And let's see if I could replicate it. And let's say I have a private, we'll just make this simple here. Private string, first name, private string, how about a middle name? Pedestrian kind of stuff here. Pedestrian string, last name. All right, there we go. And let's create a constructor where we will create a constructor for all of these. Okay, well, one of the things that I saw as well, I don't know how new this is, but take a look at this. These two right in here, and let's see if I can focus on these. Yeah, there they are. How many IntelliJ users here? All right, that's a good group. All right, so when you do your Alt-Enter on your constructor, I don't know if you know this, but we have replaced constructor with builder. Okay? Some of those couple of design patterns that I had just referred to. Let's see how good this works. I probably don't have a lot of information here yet, but let's see if this works. It may or may not. So here's the builder class. Here's the package for it. This looks pretty good. Let's see, what do I need to check here? An optional setter for this. I won't do that. Yeah, let's see if this works. I don't know what I'm doing on this one. So we'll see what happens. All right, let's take a look here. And there it is. I think there's going to be like, some kind of tweaks that you would have to use. Like, I don't like the word create person. I may just rename that to build, just like all the other kids are doing it, right? But here it is, and here's that builder. So I could just say person builder and start off and then start to create this person. And because I have that, then I can lock that up. So there's always room for the builder pattern. One of my, colleagues, and James Ward. James Ward does not like that particular pattern, and it's all about functions, which I'm all for. Like, I'm all for, hey, let's do functions. But one of the things that I found interesting is that the builder pattern is out there without us really even consciously knowing it. Okay, I give you the following. Let's see. I give you list. Ooh, yes, list. All right, let's try this here. All right, and I think most of you know this already, so I'll just call on you to shout it out. All right, let's see here. Let's do var ls and list of. Okay, great. Isn't Java great? Look at that. All right. What will this be when I hit enter? Nothing. No, hopefully not nothing. Let's see. Maybe nothing. No, there it is. Reference pipeline. Right, you get this junk, right? If you ever ran this in JShell. By the way, JShell, wonderful tool. And if you don't use it often, give it a try, because I really like JShell plus TDD. It's a magnifique. All right. So what happens then if I do this? What kind of type do I get back? So let's say I want to go multiply by 4 on each one. What do I get back? A reference pipeline, but a different hash, right? So there's like another kind of like object being returned here. What happens then if I filter it? Let's say things that are modulo 3. What do I get back? Something bad. All right, here we go, one more time. All right, here we go. Boink. Reference pipeline. It's almost like this kind of builder object is being returned each and every time. And then what's the thing that terminates it? It's kind of like what? A reduce, or toList, or collect, or any one of the terminal operations, which to me, well, hooray for our result here. But very much like a builder pattern in that I trigger things off like with stream of or a collection dot stream, and then I do all these also in whatever order that I want. That's one of the benefits of that builder pattern, is that if I want to add skim milk on top and then decide to add sprinkles later, or vice versa, in whatever order I want to use, that's what the builder pattern is for. This is hiding complexity from your end users. That's the benefit of a builder pattern. So I still have love for a builder pattern. Okay. Anybody know what currying is? Currying? Okay. Some yes. Okay. Some are like, that sounds delicious. But no, that has nothing to do with it. All right, well, let's take a look here. I consider this a modern version on the builder pattern, I think. Yeah, I'll go with it. Heck, I'm here on stage. I might as well go through with it. Anyway, so here it is. Record. This is what you're missing out on. Love records. I can create a class on the fly, right then and there. Take a look at my line number 7. Record person, this has toString equals hash code, everything that I as a programmer desire, right? Creates getters, but we don't call them getters, we call them accessors. It doesn't have the word get, so a little bit different. These are final, so once you create it, you're done, right? No immutability. Well, it is immutability, so no changes whatsoever. But what curring is making down payments using functions, essentially. So, yikes, what is this? So this one is, you know what, if you give me a first name, fine. What I am going to return then is I'm going to give you a function that will be, if you give me a middle name, I'll return you another function. And if you give me a last name, then I'll return a person. Okay? It's continually making a down payment using functions, which is kind of like a builder pattern, right? Again, the only difference is you got to do it in order, not like the builder pattern, which could be in whatever kind of order that you would like. But once I supply the first name and the middle name, then what gets returned is a function that, hey, if you give me a last name, then I will finally return a person to you. That's curring, right? And so what I could do is, let's say here's that function, which is, let's start off with first name, and then let's start making down payments on it. So let me provide Thomas. What is that going to do? Well, that's going to return a function that if you give it a string, that will return another function, right? Then once I have this, after applying first name, well, let's take that function and apply it with Falco. I was listening to 80s music, I think. And what I get in return is now a function with string and person. But here's the thing, and here's the great thing about functional style programming, is that once I have a particular handle on something, I could reapply it in many different ways, okay? Let's see. I don't know. Trying to think of a middle name here on stage is kind of hard to do, but there it is, okay? So if I wanted to, and here I'll call that one person 1, I could take that handle and run away with it in a different direction. Okay? That's one of the best parts about immutability. This is one of the best parts of functional programming. So, if builder pattern doesn't quite fit, consider curring. Let's see where we're going to go to next. Singleton. How many of you were programming circa 2000 to 2004 in Java? Anybody? How many of you remember the overuse of singletons of that group? Everywhere. Oh, I'm going to create this one thing. Let's make it a singleton. What? What happens if you need multiple instances of that? I don't know. Others are creating singletons, so let's go with that. And then it just caused a few headaches. Let's determine your love-hate relationship with singletons, those who know it. How many of you love singletons? Let's go. 1, all right. How many of you hate singletons? I was expecting more hands. All right. All right. So singletons kind of have a little bit of a bad rap, but yeah, let's discuss it. So singletons, and in fact, let me use my slides on this one because got a lot of different ideas to run past you when it comes to singletons. Now, singletons, I'm talking about the pattern, not hey, I'm going to go to Spring and just declare this one as a singleton, thus creating only one object. That's still a singleton, and I'm in favor of that. In fact, I'm in favor of typically not using the singleton pattern at all, and just ensuring in that your code that you create a single application using like a Spring framework or a Juice or something like that. But here it is. Let's talk about the singleton pattern. All right, groovy. So it is a creational pattern, and I think many of you know this, but the thing about the singleton pattern is that you have to do it right. Particularly if there's going to be thread contention, then things can go really wrong. But it ensures that you have a single object at all times. But I think there are a lot of disadvantages. Disadvantages is abuse. You get a lot of them for sometimes no reason at all, sometimes good reasons. I'm going to deny that. Difficulty in unit testing. often unnecessary, particularly if you have a Spring or a Juice, like a dependency injection framework. No control over who accesses the object. Once you go Singleton, that's tough to change and can expose threading issues where duplicates are created. So you got to do it right, particularly if you have multiple threads going on. Now, you could make it eager to where that Singleton is created on the spot. You could create a bad Singleton. I mean, this one looks pretty good. I think that one's wrong. That should be 2 equals. But you could call a get instance here, but that could suffer through some thread contention there. So putting a synchronized would typically be the right thing. But like I said, we've got a lot of new things in Java, and I think this one I learned from Effective Java as well, and that is create a Singleton as an enum with one thing called instance, and you are done, okay? And there's that Singleton pattern. So you can save a lot of time for doing that. And remember, an enum can have methods very much like a class. This just has one single item that represents it. So use that as your new Singleton, okay? If you must, okay? And sometimes you do. Sometimes you need that one particular object and just because it's holding something, or there could be varying reasons for it. All right. State pattern. Any of you know the state pattern or use it, or it's a main component of your software nowadays? State pattern, state. Okay. I've always found this one intriguing. Let's take a look. So let me show you the classic pattern first, and then I'm going to show you and tell you a story. Nothing beats a story where you're humiliated, am I right? So we'll go with that one here in a bit. All right, so next one, let's take a look at the classic Gang of Four, 1994 design pattern, the state pattern. Okay, well, I made this one a little bit simple. Let's take a look here. And again, things have changed, so let's see what it was way back when. So this one, we have an off state. So this is just a switch, right? Either your switch is off or on, or off or on. The great thing about the state pattern is that it represents an object of what state you are currently in. If your switch is off, that's your state. You're in the off state, okay? But it also knows that whether we execute it or do something with it, then we jump over to the next state. Now, this context is what's going on. What's the context? What is this switch at? Now, here's the thing. There's a little bit of mutability here. As was the case in 1994, we had objects with a lot of mutability. Unlike today, we're trying to shy away from that mutability. But given this context, if someone hits execute, then we're going to set the state. So right now, this is the off state. So if someone says execute, then we're going to tell that context which holds that state, hey, let's go to the on state, and let's pass this context over here. Here you go. This is the current state, okay? And then now this is on the on state. So what does the on state look like? It looks like this. And if you click on execute, again, this context is going to be essentially injected in each one of the states, so that way it knows what to pass on for each and individual state. All right, humiliating story time. So I like teaching TDD. I also, every once in a while, 90% of the time, sometimes I let my arrogance get ahead of me. And then it all falls apart and blows in my face. Anyway, so what happened was, went to a company to teach TDD, and I decided, and by the way, this is a great site. I decided in my infinite arrogance, hey everybody, let's go to CyberDojo, not CyberDog, that's weird, cyberdojo.org. Okay, internet's not down. But take a look at cyberdojo.org. And on there, they have a lot of different kinds of tests that you can use for test-driven development. So here's my infinite arrogance. Just choose one. I don't care which one. Just choose whichever test and we'll solve it because TDD is so wonderful, right? You know where that's going to go. So, and you know, the audience was really gracious. They're like, this one can't be too hard, can it? Let's go with tennis. I'm like, all right, tennis, great. But then we started to design the tennis app using TDD. And then what we had was like if, else if, else if, else if, we had this like long list. Everything was fine. In fact, I don't think, as the instructor that day, I failed. I truly didn't succeed though, and I was a little bit bummed out because it got really hard, and you know where it got hard during advantage, right? In tennis, you kind of tell, hey, you're 40-40, but if someone scores, then they're at advantage if only the other player is at 40, right? That's where it gets complicated. But if that person's not at 40 and one is at 40 and they win, then they win, or then they score, then they win the game. Like it's that advantage where things started like breaking apart, just like, oh my God, that's crazy. All right, so what I did was like, all right, that didn't go as well as I thought. It went all right, but it didn't go as well as I thought. Got on the ferry at San Francisco, riding on the ferry in San Francisco, got a beer, sitting there on the ferry. And when you're not thinking about things, that's when you're at your brightest. Damn it. State pattern. State pattern would have done it. State pattern is wonderful. State pattern is great. And here's the thing about a lot of these design patterns from 1994. With the exception of, I think, Singleton, all of them are unit testable. That's one of the great things about these design patterns as well. And I don't think it anywhere says it explicitly, but there's always a way to test it. And in fact, sometimes it even makes things easier to test. And the state pattern does that because you have one object representing that state, and it could go either direction. You just focus on that one object. You don't focus on, a lot of if statements and just throw a bunch of conditions and hope for the best, then it gets all mangled up. So that's where the state pattern really shines. Now, I just showed you a basic one. So I decided that was a terrible day. So let's do a tennis game this time. And so here's what I mean by simplicity. And let's modernize it with a record. So this one is love. Okay, I'm all about love. I love all of you. All right? No, I do anyway. So love is 0, right, in tennis score. Okay, so we are at absolute 0. So, but they call it love, right? Because no one wants to be called a 0. People want to be loved. So on this one then, if somebody wins, then all I want to know is the opponent's score, because that may have relevance on which state I need to go to next. What is this 6 through 9 magnificence that I see here? Right? This is the new switch. I had avoided switch for so many years, I forgot all about it, right? But now switch has different behaviors. And this opponent score here is a score. What is a score? Now let's take a look here. Oh, I love you, Java. Look at that. So this is a sealed interface. A sealed interface is going to be an interface which determines how many children it has. And it's kind of like final and abstract all at the same time, but it determines how many children it has. So this says score, I'm going to determine all my children. They are advantage, that'd be a great name for a kid, right? Advantage, 15, 40, lost, love, 30, and 1. That's it. And I'm going to define them all. I'm still trying to navigate and swim through these waters. I'm leaning for these sealed interfaces if things are going to be a little bit different, and there are going to be some things that you'll find that with enums, they're not going to quite fit perfectly, and I think you're going to try to do a trade-off between enums and sealed interfaces. I think they're very, very much related. One of the things that are going to be of a difference to me is if the signatures are different. Like if you picture the planet, I think everyone knows the Enum planet from the Java website, where it has Mercury, Venus, Mars, and they have the radius, and they have 2 parameters. One of them is the radius, and the other one's the weight, I think, the planetary weight. All planets have those particular properties. But if like advantage 15 or these right here don't have the same parameters, then you're probably better off going with a sealed interface. So in my mind, they're nearly equal to one another. But this is great because with this then, I have this particular interface and I declare who all the children are. That's who I'm permitting. And all of these are typically going to be a final class or a record of some sort. All right, nice. So what was about this love state? Okay, it's always great being in a love state. But this one was, if someone wins, well, let's determine by this score here, well, if my opponent won already, then this is a moot point. I'm just going to return I'm still in love. If my opponent lost, then it's a moot point. The game's already over. But otherwise, we're going to move to 15. Hence, let's get over to the new state. Bravo. Well, here's that one. And again, I'm using some of the new features. Well, take a look. This is a record. That's new as well. So this is an immutable object, but I'm switching on that particular opponent's score. What's next after 15? Then 30 is. Let's look through all these. So all of these are kind of like pretty basic and pretty template-y, I guess. But here's where things get a little bit interesting. So if my opponent won, fine, we're in this state. Or they lost, well, I'm still going to stay in this state. But let's see. If I'm at 40 and my opponent's at 40, then I go to advantage. And see how nice and clean this is? Because I'm only focused on this one particular stage. And that's it. And I can move to advantage. If I'm at advantage, I stay at this. But if I win, then or any other condition, I'm just going to move to a state of 1, and the game is over. Now, how do I use this? Oh man, here we go. So here's my redemption, I hope. All right. And in fact, here, let me do this here. So I have a critical moment here. Let me break this up again, because I was doing this, trying to rehearse it a little bit yesterday. Let me do an inline here. There we go. I decided to design it like this. And this is not the end-all be-all. Again, there's just opinion on my part. You decide however you want to design things. But this one is kind of like, anybody do Scala here? Okay, great. Oh, I'm over here. There's something called a different kind of state functional pattern that uses flat map. It's monadic and has all these wonderful terms to it. I kind of want to model it after this, but I didn't want to do like the flat map sort of thing. So I wanted to make it a little bit readable. So I went ahead with this one, where the context is the tennis game, where I'm going to start a tennis game. Oh, static method. Nice, right? I'm starting a game. I have an actual verb for it. And this is between Salvador and Rafael. And what I'm deciding to do here is, for this tennis game here, let's start to play tennis. And again, I'm not trying to sell you wholly on this. This is just, again, an opinion of mine. But this one is my take on the state pattern, using records, using switch, and bringing it all together. So tennis game dot next turn, and what I have here is a function. And this is just a plain function that, given 2 parameters, either it's Sal or it's Rafael, and I'm going to determine who the winner is for that turn or for that particular round. And then along the way, I'm going to hold on to that particular state. Now, let's say right over here, and so one of the great things, again, about functional style programming is that with immutability, I can break the chain wherever I want and then hold on to that state and then break apart from there. Okay, essentially just fork from it, which I think many of you already know about that. So what I'm going to do is I'm going to create a variable out of this, and here it is. So I'm going to say, game is tied here. Okay, break that up. So this one, tied, I hope if I did this right. If I didn't, I apologize in advance. Let me do tied, and let's do the score here, and take a look at what it is. So Rafael had scored, and then Sal had scored. Let's see what we have. Okay, good thing everything's working well. Let me go ahead and expand that, and there it is. 15-15. Woohoo! Nice. All right. So this is when we were at 15-15. But look how easy this is going to be, I think, for the users, is that we are progressing state, and we have a decision factor. depending on who's going to win each and every round. So this result game, now take a look at this because I was focused on each of the individual states then. So I have Raphael, Sal, Raphael, Raphael, Raphael. So Raphael is going to be the winner in this case, but I'm still going to add like Sal is going to score and Raphael is going to score, which is kind of like an invalid state. But yeah, let me go ahead and run this again. So Raphael should win on this one, yeah, and there it is. And Salvador only had 30. So one of the best things about it is, I'm hiding that complexity away from the end user. I'm using functional programming. I'm giving them an API that looks like, they're just discussing a game. I wish to start a tennis game between two players, and here we go. So what's the next turn? And I decide who's the winner, and then I maintain the score that way. That's what the state pattern is, but you don't have to adhere to the classic way. You have a lot of tools at your disposal. Okay, love that one. All right, what was I going to talk about as well? All right. Running a little bit. Oh, I already talked about strategy. Let's talk about, I got about 10 minutes. I may come back, well, let me just talk quickly about chain of responsibility. Let's come in over here. Let's take a look at it. So here was the chain of responsibility, and I think it was kind of messy. I don't know. Anybody know about the chain of responsibility? Use it often? This is the 1994 classic way, which is, it's kind of like a state pattern in that I am a reviewer. This is for car and buyer, and whether they want to put their stamp of approval for a particular car. And given a car, if they have passenger airbags and driver airbags, then boom, seal of approval, car and driver recommends this particular vehicle. So let's take a look at another one. Here's Carfax. I don't even know if they do reviews. But here it is. So this one is, well, if they have airbags, not too picky on this one, then they're going to go ahead and approve it. Let's take a look at another one. Did something there. Ooh, I did one Carfax. There we go. All right, and here's J.D. Power. J.D. Power is adding a little bit more pickiness to this. So there's a rear view camera, a drive lane assist, and power steering. Oh, that says Carfax. Then it's going to give someone else's company's recommendation for it. There we go. So there's J.D. Power. Now this one is, this is going to be chained, and that's the classic way to go about it. Now, how do we run this? Well, this one's kind of, I think, sloppy for nowadays, where we have a car, but the thing is, here's the interesting thing about it. The classic way was, hey, let's put the list of recommendations inside of the object. Is that really even a part of the car? So this one just seemed kind of odd. Yeah, that was a classic pattern. So I have make, model, Accord 2011, seat coolers, drive lane assist, and whether they had all these features. But it held that information internally to it, which again is a little bit odd. But then what we had to do was chain these together. This is very much like kind of like filters in the servlet spec, where you can like filter the requests and the responses, where you can chain those things together, and then you would do a recommend car. And when you run this, then you would have the recommendation. Carfax would, see that over to J.D. Power, and then from J.D. Power, that would go to car buyer, and what you would end up with is all the recommendations for that particular car. But it's funky, right? It's crufty and not very modern. So how do we go about that for the chain of responsibility? I found that, one, create a record of all the different features. That's already your model, nice, clean. It has your toString, your equals, your hash code, everything that you want. So that was easy. Here's the reviewer, which is, oh, look at this. Oh, this is going to be so sweet. All right, I'm glad I talked about this one. So this one is, hey, let's bring in a car, and then let's return an optional of string. How many of you love optionals? Come to love it forever. All right, cool. Okay, so next, take a look at this right here. All right, so here it is. So this one is a reviewer. So what is this? Here, let me convert that to an anonymous class here. Look at that. Reviewer car and buyer is equal to new reviewer. Same thing. Do I have to create extra classes for it? Well, I guess I didn't have to from before, but I now have an excuse now in that every reviewer has this, hey, I wish to review a car, and then I have an optional of string on whether this has an approval or not. And if it does, then it's going to have the name of that reviewer. But this is an anonymous class with one abstract method, and all is good with the world, so I can just convert that to a lambda. So I have 3 lambdas now for car and buyer, for Carfax, and JD Power. So what I can do then is let's do a stream of reviewers. Okay, these are the ones that are going to either approve or disapprove. And then I have my car. And what I'm going to do is I'm going to send this car in and decide whether my approvers will approve of this vehicle that we see here. All right, now, what is this funk right over here? This is one of my favorite things in the Java programming language. Well, let's take a look at what the type is here. And I don't know if you can see that. This one is optional of string. For all IntelliJ users, that's Control-Shift-P, which is called type info. So select whatever it is that you need, and then you can just do a type info. So that shows an optional of string. One of my favorite API calls is, once you have an optional of anything, call a stream of it. So let's highlight. And then let's do a type info. Stream of string. Ooh. There it is. Okay? So this one's a stream of string. And so if I have an empty stream and a flat map, what happens to that stream? So in other words, I have streams inside of a stream. But if one of them is empty, what happens, right? Someone did poof. Or the way I like to call it, right? It gets scrunched. It gets removed out of here. So all you're left with are the optionals that have something. All the ones that are empty, scrunch. They're out of there. They get booted out. And so that's why for this, you're able to get a clean set of approvers. Right? And there they are. Okay? You don't need all the extra classes like you did before. All right. Running a little bit out of time here, so let me be a little bit strategic here and cover the ones that I wanted to cover. All right. On the last few minutes here, I love and will always love the adapter pattern, and I don't think there's anything wrong with it. One of the things that I learned is that through TDD, I've learned to respect my code. Right? You put a lot of effort into it, and when you do so, put a lot of that effort into it, you tend not to want to break things quite as easily, and you tend to want to work away around it. Some call it like open-close principle. Same sort of thing is that, what you develop, you kind of want to just keep and maintain and try to strategically decide how you want to work around it. So adapter pattern is absolutely great, okay? It's just you wrap around something else, and in this case, I have a Celsius thermometer that I'm going to plug into this adapter that's just going to convert that number for me, or whatever kind of conversion it is. If I need to make a change, and if someone comes by and says, I need you to make a change, don't panic and don't destroy your code so quickly. You have options. And one of those options is going to be the adapter pattern. So you wrap that up, nothing wrong with the classic pattern, but if you decide to, there are some other ways to go about it. You can implement the adapter pattern with a function as well. By the time you convert everything to those functions, it may look a little bit odd, but I don't think it's too bad here. In fact, I could go even one more round here to where, it's kind of like currying, where I'm just passing this centigrade over. And this one is just going to then take that temperature using currying and get you whatever it is you need. So you could achieve the same thing with a function. And then last but not least, Let me bring this one over. And again, if you go to this particular presentation, this one's testing the undesirable. This is what I look like with a beard. Look at that. I submitted that picture to Microsoft where it tells you like how old you are. Added like 10 years to me, and so I decided, nah, let's not do that. All right, sorry about the scrolling here. Shield your eyes if it bothers you. But the one I'm going to go to on here is, so a lot of these are like techniques that I learned from Michael Feathers' book on how to do things judiciously in affecting change. But the one I'm going to go for is wrap class and wrap method. So this one's wrap method. I'm going to skip those ones. But I'm going to go to wrap class, which is probably going to be one of my favorite ways to describe the decorator pattern and why it's one of my favorites. So if someone comes up to you and says, hey, you're doing a deposit into this bank, but we need auditing. What now? Okay, well, I need to make a change. Let's break this code. No, let's not do that. So there are a lot of refactoring strategies that you can use. One of my favorites is called extract interface. You have this in IntelliJ IDEA. Command-Shift-A and then just type in extract interface, or Control-T. That gives you your menu for doing a refactoring. And one of them is extract an interface. So if you have a concrete object, oh, hey, I come with sound effects. That is creating an interface out of it. And here it is. But now that you have this interface, what you can do is create either a different implementation or an implementation that essentially wraps over the old one. And now you're affecting change with it. This is why decorator pattern is one of my favorites. So I can wrap around another foo, and this one's called a foo logger, with a deposit on here. I can then do TDD to design things really nice to make sure that I'm not adding bad code upon bad code. I'm actually creating really good code, right? And so here's the TDD. Now, I know my time is up, but here it is. So what I'm able to do is I'm effectively able to produce the audit before I call that core method right here, which is foo deposit. This foo deposit here is going to be the original method, but I'm affecting some sort of change. I'm affecting some sort of wrapper around it without actually even touching that original code. I am creating another class that essentially, again, wraps around it, and therefore I'm affecting change with it. That's pretty great. There's nothing different about it. I'm not changing it in any way, but I just want to make sure that I promote this one, because this wrap class, whenever you generate the UML for it, what you'll find is that this is exactly the decorator pattern. So if you are thinking about doing some changes, think about using a pattern instead rather than just hacking and breaking along the way. All right. Hope you enjoyed it. Thanks a lot, everybody.